Jupiter is not just the largest planet in our solar system. It is a world of violence on a scale that is almost impossible for the human mind to fully grasp. When we look at its swirling clouds through a telescope, it may appear beautiful, even calm from a distance, with its soft bands of orange, white, brown, and red wrapping around the planet like painted silk. But this beauty is deceptive. Beneath those cloud tops lies a raging, never-ending system of storms, jet streams, and magnetic forces so extreme that they would destroy anything resembling Earth-like life instantly. The storms of Jupiter are not weather in the way we understand it on Earth. They are planetary-scale engines that operate using heat, pressure, and motion, and they run continuously for centuries, even thousands of years, without stopping. To understand how dangerous Jupiter's storms truly are, we have to begin with the planet itself. Jupiter is a gas giant composed mostly of hydrogen and helium. There is no solid surface to stand on. Instead, what we call the atmosphere gradually becomes denser and more extreme with depth, eventually transitioning into exotic forms of fluid metallic hydrogen under crushing pressure. Winds on Jupiter are not slowed by mountains, oceans, or landmasses like on Earth. Instead, they circle the planet in uninterrupted bands, reaching speeds of up to 400 miles per hour or more. These jet streams act like invisible highways of chaos, separating different atmospheric zones and feeding storms that can grow to enormous sizes. One of the most famous and terrifying features of Jupiter is the Great Red Spot. This is a storm larger than Earth itself, a rotating vortex that has been raging for at least 300 years, possibly much longer. Imagine a hurricane so massive that it could swallow an entire planet, and then imagine that it never dies. It does not make landfall, it does not run out of energy in the way Earth's storms do, and it does not dissipate quickly. Instead, it is continuously fed by surrounding jet streams and internal heat. The winds inside the Great Red Spot can reach speeds of several hundred kilometers per hour, and the pressure gradients are so intense that any spacecraft entering its core would be torn apart almost instantly. Even materials designed to withstand extreme conditions on Earth would fail in seconds. But the Great Red Spot is only one example. Jupiter is covered with storms, both large and small, constantly forming, merging, and disappearing. Some storms are white ovals, others are brown or red, depending on their altitude and chemical composition. These storms can last for years or even decades. They are not isolated systems, they interact with each other, sometimes merging into larger storms or being shredded apart by faster jet streams. The atmosphere behaves like a living fluid, constantly reorganizing itself. One of the most dangerous aspects of Jupiter's storms is the vertical structure of the atmosphere. In Earth storms, such as hurricanes, there is a relatively thin layer of atmosphere involved. On Jupiter, storms can extend thousands of kilometers deep. As one descends into a storm, pressure increases dramatically, and temperatures rise to levels that can melt and vaporize spacecraft materials. Clouds are not made of water like on Earth. Instead, they consist of ammonia ice, ammonium hydrosulfide, and water clouds at deeper levels. Each layer is chemically different, electrically active, and dynamically unstable. Lightning on Jupiter is another terrifying phenomenon. It is far more powerful than lightning on Earth. These electrical discharges can be up to 10 times more energetic than the strongest bolts observed on our planet. They occur deep within storm systems where water clouds exist under extreme pressure. The energy released in a single Jovian lightning strike could power a small city on Earth for days. These flashes are not just surface phenomena, they illuminate deep cloud structures hidden from visible light, revealing a world of violent electrical activity. The storms are also influenced by Jupiter's enormous magnetic field, which is the strongest of any planet in the solar system. This magnetic field traps charged particles from the solar wind and accelerates them to high energies, creating intense radiation belts around the planet. When these charged particles interact with the atmosphere, they contribute to auroras that are hundreds of times more powerful than Earth's northern lights. However, this radiation also makes the environment extremely hostile to spacecraft and would be lethal to unprotected humans within seconds. What makes Jupiter's storms particularly dangerous is their unpredictability on human timescales. While scientists can track large-scale patterns, the fine details of storm formation and evolution are chaotic. A seemingly stable region of atmosphere can suddenly erupt into a massive storm. Jet streams can shift, merge, or break apart without warning, reshaping entire weather systems. There is no seasonal stability like on Earth. Instead, Jupiter exists in a constant state of atmospheric warfare. The energy driving these storms comes from two main sources. The first is internal heat. Jupiter emits more energy than it receives from the Sun because of leftover heat from its formation and ongoing gravitational compression. This internal heat rises from deep within the planet and drives convection currents that fuel storms. The second source is the planet's rapid rotation. Jupiter completes a full rotation in just under 10 hours, which creates strong Coriolis forces that stretch storms into bands and vortices. This rapid spin is what organizes chaos into structured belts and zones while still allowing violent turbulence within them. If a human spacecraft were to enter Jupiter's storm systems, the experience would be unlike anything encountered in space exploration so far. The outer cloud layers would appear deceptively calm at first, but soon the vehicle would be struck by violent turbulence, electrical discharges, and extreme winds. Communication would become difficult due to interference from radiation and atmospheric noise. As the spacecraft descended, pressure would increase rapidly, crushing any conventional structure. Even if the craft somehow survived the mechanical stress, the heat and chemical composition of the deeper atmosphere would eventually destroy it. The idea of falling into Jupiter is misleading because there is no solid ground to reach. Instead, a falling object would be gradually compressed, heated, and dissolved into the surrounding gas layers. Eventually, it would become part of the planet itself, indistinguishable from the surrounding atmosphere. Another hidden danger of Jupiter's storms lies in their scale and energy transfer. Storms can transport energy across thousands of kilometers, affecting weather systems on a planetary scale. A disturbance in one region can trigger changes in another, leading to cascading atmospheric effects. This interconnected system means that Jupiter's weather is not localized, it is global, dynamic, and deeply interconnected. Despite all of this destruction, Jupiter's storms are also a key to understanding planetary science. They act as natural laboratories for studying fluid dynamics, magnetohydrodynamics, and atmospheric chemistry under extreme conditions. By observing these storms, scientists can better understand not only gas giants but also exoplanets orbiting other stars, many of which are even more extreme. Still, from a human perspective, the storms of Jupiter represent an environment that is fundamentally incompatible with life as we know it. There is no shelter, no stable surface, and no quiet moment in the atmosphere. Everything is motion, pressure, and energy. Even the most advanced technology we can currently imagine would struggle to survive for long in such conditions. In the end, Jupiter's storms are not just weather systems. They are expressions of a planetary-scale engine that has been running for over 4.5 billion years. They remind us that the universe is not always gentle or predictable. Sometimes it is violent beyond imagination, governed by forces so large that human experience can only begin to comprehend them. And yet, from this chaos, we gain knowledge, perspective, and a deeper understanding of how strange and powerful nature can be.